Start recording. Today is the 4th of December, 2017. So however many Skittles you have, however they got to your island, we don't know if they floated over on little log rafts, we don't know if they can fly or if they swim or if humans drop them off, but you've got this population of Skittles on your island. Now, let me ask you this. Are all your Skittles the same? No. What's different about them? Color. So within this species, this skittle species, we have one immediate piece of diversity, which is color. You know how to graph a population based on a characteristic, how to make a bar graph. Some of you have already done it. So go ahead and count up the number of Skittles in your population. You will have to separate them by color, obviously. And make your bar graph. So while in the back, we have rule-based predators. They are selectively preying on Skittles for some reason. Up here in the front, it's going to be random predation. How do you randomize things? Here's what I'm going to tell you. Your brain is not fair. Your brain cheats. It really does. Given, if I tell you randomly pick one, you're going to unconsciously pick something. There will be an unconscious selection process. So many years ago, I worked as a watershed coordinator. Who here has ever worn chest waders? Nobody? Chest waders? Big rubber boots that go up over you all the way up to here, and you go out in the creek? You're going fly fishing, you might wear them? Okay. So who has worn chest waders in December? Who has worn chest waders in December and picked up 100 rocks from a creek? I have. It was miserable. Well, because I was doing a pebble count. So a pebble count is a way of determining how much energy a stream has by seeing what size rocks it can move. And you create a distribution, just like these, of the pebble size in the creek. Now here's the funny part. You have to plant your feet in the creek, bend over, touch a rock. The first rock your finger touches, you measure. You record. But that part about your brain cheating, if you open your eyes and try to touch a rock, you will unconsciously go for larger rocks. So to do a pebble count, you plant your feet, close your eyes, put your finger up, and do that. And the first piece of substrate, the first thing on the bottom that your finger touches, you pick up, you measure 100 times in 3 different locations. It was December. Did I mention that? The good news is your hands stop hurting once you can't feel them anymore. So, seriously, they do. To randomize your preying on these defenseless Skittles, you're going to need to do something. Because if you open your eyes and go to randomly grab a Skittle, it's not going to be random. So, you will have to remix your colors if you sorted them for counting. Don't drop any. Especially you have a very small starting population. You can't afford to lose anybody off the island. They drowned, they never came back. So, once you either have your rules in place, or you've got your stuff shuffled here. Oops. That's why we alcoholed the desks. Okay, there we go. Once you have that in place, you can go ahead and eat how many Skittles? 5, and that's for the whole table. So if you have 4 people, everybody gets to eat 1, and then one person gets to go again. Don't worry, we're going to have multiple rounds here. So you go ahead and prey on your Skittles, and then I'll be around to repopulate your island. And you went through, I think we said 3 generations. Anything different? I mean, their population grew a little bit. The absolute size of their population is a little larger. What other differences do you notice in their population? Did you guys have all colors represented in your founding population? Yes. Yes. We happen to know that with this species, Skittletaurus, there are 5 color variants that we find in this species. And starting off, the population on their island had all 5. What happened after 3 generations? Oh, the orange Skittles went extinct. They were gone after 1 generation, so they disappeared pretty quickly. Okay. Now, over here we have a slightly larger population. And that was back there. And you guys were systemic hunters, right? You had a system? Okay. I probably should have gone with them, but that's okay. So, what was your original founding population? How many? 42? You had 42 Skittles to start with? Wow, that's a lot of Skittles. Your very first, the number I dropped on your desk was 42? Huh. I trust you. Okay, I'm not going to count. Okay, so they had a much larger population where these guys had, what, 2, 4, 6, 8, 10, 11. Much larger population, like nearly 4 times as large. Did you guys have all colors represented to start with? Did you have all 5 colors? Yeah. Did you have all 5 colors 3 generations on? Doesn't look like any colors went extinct. Yeah. Okay, interesting. So, when you have graphed the population that you have, your final population, if you flip to the back of this packet, there's a set of questions. And, oh, I know what I should have done. I know what I should have done with yours. I want to take one more picture. I'm going to take a picture of yours. I had these guys, and did you start off with all colors represented? Yeah. You did. And then the red went extinct at some point? Yeah. In the second round? Yeah. Okay, so they had no more red, but then in that last round, when I was replacing their Skittles, when they were reproducing, look what happened. They got a red Skittle. How weird is that? Oops. Very weird. Okay. Bad news I have for is you're not turning this sheet in today. You're not answering all these questions today. You're going to have to hold on to this for a few days. If you do not trust yourself to hold on to it, you may put it in the box for your class and come in and get it when we come back together every day. But some of these things we haven't talked about yet. And so I want to have you reflect on these as we talk about them. If you know that you graphed your final population correctly, you can go ahead and, as you work on the questions, finish eating, basically making Skittles extinct on your island. Gesundheit. If you're a lizard on a log in the middle of the ocean, you might get to an island or you might drown. Those are kind of your possibilities. If you're the only one of your species who gets to an island, will you establish a population? If you're all by yourself. No. Now, these guys reproduced how? Sexually or asexually? If there were 2 yellows, I gave you 2 more yellows. Each yellow had 1 yellow baby. Asexually, yeah, they reproduced asexually. 1 parent, 1 offspring. If you had no green Skittles in that initial population, that founding population, what are the chances of you getting green Skittles later? Well, we won't say absolutely 0, but probably pretty slim. We know that green exists as a variation in Skittles. Is it possible that you would have a mutation? Yeah. So let's think about this idea that we talked about last week with our blue-eyed mutants. Can having a mutation pop in, change your distribution by presenting some new option? Yeah, it can. Now, I gave you guys a mutation in the last bit. I didn't give anybody else a mutation. Can it happen? Yes. It can. Now, oh, and I already told you to start eating. Darn it, I should have done some emigration. I know. What is founder effect? Who thinks that at their table they came up with a good answer for that? Something about your starting population. So, looking at this, let's imagine, I should have taken a picture of one that didn't have that. If that's our founding population, oops. If that's our founding population, we have no green, is it likely we'll get green? No, it could happen, but it's not real likely. Founder effect is this idea that the variation in your population is limited by the variation that's present in your founding population. Who starts the thing? Who starts the thing? That's what founder effect means. In essence, that the amount of, you're not going to get a whole lot more variation in your population unless you have lots of mutations than you had in your initial population. I'm going to write that down. You're not going to typically get a whole lot more diversity in your population if you have a not diverse founding population. Okay? The more diversity you have in your founding population, the more diversity you'll tend to see in that population as time goes by. Now, nobody had their population totally crash, did they? But did a lot of groups lose genetic diversity? And that's what we're going to talk about. So this whole week, up until Friday, of course, we're going to talk about what we saw here and relate it to the evolution of populations. One other item. On probably tomorrow when you walk in, I'm going to ask you to join a separate Google Classroom class based on your Friday group. That's going to make it easier for me to shoot assignments and updates and important things out to just the folks who need a particular thing. And if we have any shifts in the groups as we go, I'll just add you to another class and subtract you from that one. But look for those tomorrow. They'll be on Classroom. In the meantime, you need to hold on to this packet because we have not talked about a whole bunch of stuff in there yet. If you don't trust yourself to do that, stick it in the Bio Period 6 box for safekeeping while you continue to prey on those defenseless skittles.